Hello, fifth grade. I want to go over lesson 4-6 or multiplying by decimals that we worked on today in class to give you just a quick overview of what we did so that if you needed to reference back here, you could look back to get a little bit of help. I want to show you our notes quickly that we took today. So we looked at taking regular multiplication, whether it's 1 digit by 1 digit, 2 digit by 1 digit, or 2 digit by 2 digit, and just solving that multiplication problem. We then added decimal numbers to these same numbers, the same factors. We just added some decimal points in, and we talked about how if we have a decimal point in one of the factors or both of the factors, we're going to count how many digits are behind the decimal point in the factors, and we want to have the same amount in the product or the answer to the multiplication problem. So in this problem, 40 times 3/10, we see we have 1 digit in this factor and no digits in this factor behind the decimal point. So we need to have 1 digit behind the decimal point in the product. When we look at this example, there are 2 digits, the 1 and the 4, 2 digits behind the decimal point in this factor, and this factor has no decimal point and no digits behind it. So when we wrote our answer, we needed to make sure the decimal point was 2 places over, and there are 2 digits behind the decimal point. We moved the decimal point to the left because our product has to be smaller than what we started with. When we did the regular multiplication problem, we ended up with 448 as the product. In this answer, it's 4 and 48/100ths because this problem is telling us we're taking a part of 32. A fraction and a decimal are the same thing. They mean taking a piece of something, so our answer needs to be smaller. We wrote the notes. We have to have the same amount of digits in the product as we do in all the factors. So we count them up in all the factors, which are the numbers that we multiply by. We also talked about the different steps to get us to the answer. So we go ahead and multiply like normal, ignoring the decimal point. Then we're going to count the number of digits behind the decimals in both factors. So this one had 1 digit and this factor had 1 digit. And then we're going to make sure that we have 2 digits in the product. Then we put the decimal point in the product so it has the same amount of digits as the factors. So those were the steps that we worked on today. We also looked at doing a little bit of partial products or multiplying by 3 digits. So whatever way makes you the most comfortable is the way that you're going to want to work on these problems. So I'm going to do a problem that looks like this. I'm going to do 219 times 11/10. So this has 2 decimal points. I see this is a decimal. This is no decimal, and I'm going to go ahead and do the math. I start with my ones place just like I was doing regular multiplication. 1 times 9 is 9. 1 times 1 is 1. 1 times 2 is 2. I'm going to put my 0 for the placeholder because I'm moving into the next place. We think of this as the tens if there's no decimal point here, and we're going to do the same exact thing. You can always use the strategy of covering up part of it as you're working through to really signify that you're doing just regular multiplication. So I'm going to put my 0 for the placeholder. 1 times 9 is 9. 1 times 1 is 1. 1 times 2 is 2. Now I have my 2 partial products, and I'm going to add them together. 9 plus 0 is 9. 1 plus 9 is 10. I put down the 0, carry the 1. 2 plus 1 is 3, plus 1 is 4. And 2 plus 0 is 2. Now I'm going to go ahead and count up the decimal points. So I have 0 decimal points, or 0 digits, in this one, in this factor, 219. And I see I have 2 digits behind the decimal point in this factor. I always think that underlining them is a great method because then you can really see that you have 2 digits. So now I need to have 2 digits in my product, which is moving the decimal point 2 places over to the left. So my answer is 24 9/10. If I was going to multiply a 3-digit number, so we'll do one like you may see in your book. We'll multiply 6.01, and let's multiply 1, 2, 9. So I could use partial products to do this, or I can multiply with 3 digits. And it's just the same thing as what I did in the algorithm, except I'm just going to have one more place, one more partial product. So I'm going to start with the 9. Remember, I always start on the right and work my way to the left. 9 times 1 is 9. 9 times 0 is 0. And then 9 times 6 is 54. I'm, again, doing the same step. So because I'm moving from the 9 to the 2, I put a 0 for a placeholder. 2 times 1 is 2. 2 times 0 is 0. 2 times 6 is 12. I make sure my digits stay lined up. And I'm going to add now 2, because I'm moving from the 9 to the 2, that's 1, and then all the way to the 1. So that's 2 places. 1, 2 places, 1, 2 placeholders. 1 times 1 is 1. 1 times 0 is 0. 1 times 6 is 6. I have 3 partial products because I have 1, 2, 3 places in the factor that I am multiplying. 9 plus 0 is 9. 0 plus 2 plus 0 is 2. 4 plus 1 is 5. 5, 6, 7, and 6, 7. I make sure that I'm adding the correct columns. And now I'm going to go ahead and see how many decimal places I have in the answer, or in the factors, I'm sorry. 1, 2 digits in this one. And this one has 0 digits behind the decimal. Oops, behind the decimal. So my product needs to have 2 digits. I have to have the same amount of digits behind the decimal in the factors and in the product. So I know I have to move this over 1, 2 times. I have 1, 2 digits, and my answer is 775 and 29 hundredths. So that is just a little bit of multiplying by fractions. Again, we follow the same algorithm, multiplying by the ones, then the tens, then the hundreds. Even if that bottom number is a decimal, we still just pretend that decimal doesn't exist and do the multiplication algorithm as we worked on it last week. If you have any questions, make sure you email and ask, and I will see you tomorrow.